on page 308. And it tells you that you are to prove that you've got that SV is congruent to VR and that this is a regular polygon. So you're to prove that PV is the perpendicular bisector of TQ. Okay, so the first thing you've got to do is you've got to start with your given statement. And I'm just going to give you the plan for this. There's 10 steps to it. I think there's 8 steps to it. I don't know why I have 10 steps to it, but anyway, I'll deal with that later. Okay, so in doing that, you're going to have to go through and mark your figure up. So you should have copied your figure. It says it's a regular polygon. So that tells you that all the sides are congruent. And you're to prove that PV is the perpendicular bisector of TQ. All right, now to do that, you're going to start by realizing that P is equidistant from the endpoints of TQ. Now, how's that going to help you? Well, remember that a line that's on the perpendicular bisector of a segment is equidistant from the 2 endpoints of that segment. Okay, and then you're going to, and you've already said that all of these, first you've got to start by saying that those sides are congruent. So you're going to say TP is congruent to PQ, which is congruent to QR, which is congruent to SR, which is congruent to TS. Okay, and you've got to list those all out separately. I'm not going to do it here because I want you to learn to write the proof. All the sides are congruent, and you want to say that because you need to prove that these 2 points are equidistant from T and Q, and that's how you're going to prove that that's a perpendicular bisector. Okay, so it's really easy to do with P because you already have that it's equidistant from T and from Q. So once you've said that all the sides are congruent, then you can say P is on the perpendicular bisector because it's equidistant from T and Q. So you're going to write this down as a step. Okay, and let's see, all sides are congruent. Where did you get that from? Well, that's from the given statement. You start with the given statement that PQRST is a regular polygon. And then you can say that all the sides are congruent because of the definition of a regular polygon. Okay, and now you've got that P is on the perpendicular bisector because it's equidistant from TQ. Okay, then you're going to draw some lines in, some extra lines. And you can do that because 2 points determine a line. So you're going to draw in TV and VQ. Now right now you don't know anything about those 2 segments except that they are, you're allowed to draw them because 2 points determine a line. Okay, now also because this figure is a regular polygon, you can mark that each of your angles is congruent. So you can mark that angle S is congruent to angle R, which is congruent to angle Q, which is congruent to angle P, which is congruent to angle T. Now how's that going to help you? Well, we've got, you should have already said that SV is congruent to VR, or you should say that SV is congruent to VR if you haven't at this point. And you've got that angle S is congruent to angle R. And then now you have that TS is congruent to QR. So you've got a side, an angle, and a side that are congruent. So by side, angle, side, we know these 2 triangles are congruent. Okay, so you can prove that those 2 triangles are congruent. Once you've proven those 2 triangles are congruent, then you can say that their parts are congruent. So these 2 parts have to be congruent. Okay, and now that we know that V lies on the perpendicular bisector of TQ because of the converse of the perpendicular bisector theorem. And then we know that PV is the perpendicular bisector of TQ because the points are equidistant from the endpoints. PV, two of the points on there are on the perpendicular bisector. And TV is equidistant from VQ, and TP is equidistant from PQ. Or P is equidistant from T and Q, and V is equidistant from T and Q. So that's your perpendicular postulate. Okay? Hopefully you could follow all of that. Should get you going.